Here we have honors algebra to math problem. So that is we have to solve for x in the given equation. That is we have to find the value of x in the given equation. Actually, the given equation contains logarithms, and here on the left side we have addition of two logarithms with the same base 7. Okay, so here we can use the product rule of logarithm. That is, whenever we add two or more logarithms with the same base, we can write the logarithm once with the base of what we have for the logarithms, and then we have to multiply the arguments. That is x times x positive 2. So this is a product rule of logarithm, and I am writing this log 15 to the base 7 on the right side as it is. Okay, now two logarithms are equal with the same base 7. Whenever two logarithms are equal with the same base, we can equate the arguments. So then I'll be getting x times x positive 2 equals to 15. Okay, now I can distribute this x to this and this, then I'll be getting x to the second power. When I distribute x to x, that is x times x is x square. When I distribute this x to 2, x times 2 will be positive 2x equals to 15. Okay, now we have a quadratic equation. Let me write this quadratic equation in standard form. That is, everything has to be on the left side. On the right side, we must have 0. But here we have 15 on the right side. So to make the right side as 0, I have to subtract 15 from both sides. So when I subtract 15 from both sides, the 15, positive 15 and negative 15 on the right side will cancel out. I get x square positive 2x negative 15 equals to 0. Okay, now I have a quadratic equation in standard form. So I have to solve this quadratic equation. So I can try to solve this quadratic equation by factoring. So for that, I have to consider the constant of negative 15 because the coefficient of x square is 1. So let's take the constant of negative 15. I have to get two factors for this constant of negative 15 such that the product is equal to negative 15 and the sum is equal to the middle term. The sum is equal to the coefficient of x, that is positive 2. So I think positive 5 and negative 3 will work. So because when I multiply positive 5 and negative 3, that is equal to negative 15. When I add them, that is positive 2, which is a coefficient of x. So x square. Now what I need to do is I have to split up the middle term into two parts using the factors positive 5 and negative 3. So positive 2x can be written as positive 5x, negative 3x, negative 15 equals to 0. Okay, even if I combine the two terms over here, it is equal to positive 2x. Okay, now I can factor this expression by grouping. That is, I consider the first two terms as one group, the next two terms as another group. So in the first two terms, I find x in common. So that is, both of them are multiples of x. So I can factor x out from the first two terms. Okay, if I factor x out from the first two terms, what do I have left in the first term and second term? To know that, I have to divide both the terms in the first group by the one I factored, that is x. When I divide the first term x squared by x, I'll be getting x. When I divide this positive 5x by x, by the one I factored, so this x will cancel out, I just get positive 5. Okay, now let's consider the second group. The second group contains two terms, negative 3x and negative 15. So both of them are multiples of negative 3. So usually whatever coefficient we have for x in the third term over here, it will be factored. So the coefficient of x is negative 3. So usually we'll be trying to factor negative 3, and also 15 is also a multiple of 3. So I'm trying to factor negative 3 from the next two terms. So what do I have left in this term? In this term, to know that, I have to divide this one by negative 3 by the one I factored out. So this negative 3 will cancel out. I have x left in this term. Okay, to know what is left in this term, I have to divide this negative 15 by negative 3. Negative will cancel. That means it will become positive. 3 goes into 3 one times, 3 goes into 15 5 times. So I get positive 5 over here equals to 0. Okay, now we have two terms. Both the terms are multiples of x positive 5. So because we have x positive 5 over here, here also we have x positive 5. So we can factor x positive 5 out from these two terms. Okay, to know the stuff left in the first term, I have to divide this one by the one you factor, that is x positive 5. This one will cancel out. I'll be getting just x in the first term. And to know what is left in this term, I have to divide this one by x positive 5. This one will cancel out. I get negative 3 equals to 0. Okay, here the product of the two quantities x positive 5 and x negative 3 equals to 0. So either x positive 5 equals to 0 or x negative 3 equals to 0. Okay, if I solve for x in this equation, I'll be getting x is equal to negative 5 and here I'm getting x is equal to 3. Okay, so I'm not sure because the given equation contains logarithms. So we have to verify the values we get for x. So we cannot consider both the values we get for x. So the values what we got for x must satisfy the given equation. So as soon as I look at this one, I'm pretty sure this one cannot be the solution because x is equal to negative 5. So if x is equal to negative 5, the argument of this logarithm will become negative 5 and the argument of this logarithm will be negative 5 positive 2 will be negative 3. So the argument of a logarithm can never be a negative value. So because the logarithm is never defined for negative values and also 0, it is defined only for positive values. So when x is equal to negative 5, so on the left side of the equation, both the logarithms have negative values. So that's not possible. So logically that's incorrect. So we cannot accept this one. I mean, x is equal to negative 5 cannot be accepted. But when x is equal to 3, it can be accepted. When x is equal to 3, so here this argument is positive and this argument is positive 5. Moreover, look at here. So here we add two logarithms with the same base. We can take logarithm once with the base. What we have, that is 7. When I multiply the arguments 3 times 5, 15. So x is equal to 3 satisfies the given equation. So the solution for the the value of x in the given equation is x is equal to 3.